In the last video, we went through the product rule in differentiation, and we said we use the product rule when we have a product of two functions. And in this video, I'll go through the quotient rule, and we use the quotient rule, as you can imagine, when we have a quotient. And let's say we have a function y equals u over v, and u and v are both functions of x. So an example might be something like, say, x plus 3 over 3x minus 5. And let's say we want to differentiate this. In general, if I say the numerator is equal to u and the denominator is equal to v, then dy over dx is given by v times du over dx minus u times dv over dx divided by v squared. And all this is saying is take the denominator is v, so take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. I believe this is given in your formula booklet, but if you do want to remember it, it is very similar to the product rule. Or it has some similarities with the product rule. So the product rule was u dv over dx plus v du over dx. And in the product rule, since we had a plus in between, since we were adding these two functions, or these two expressions, it didn't really matter which way I wrote it. I could rewrite this as v du over dx plus u dv over dx. So I just swapped these two around. I put that there and that one there. And it doesn't really change anything because it's just an addition. But since here in this case I got a subtraction, so it's important that I write v du over dx first. So if you remember this as your product rule, then instead of plus I've got minus, but I've got to divide everything by the denominator squared. Again, I think this will become more clearer when I go through a few examples. So let's take our first example. Let's say we have y equals x plus 3 divided by, let's say, 4x minus 4. Let's say I want to find dy over dx. So in this case, this is u over v. My u is equal to x plus 3. V is equal to 4x minus 4. So dy over dx will be equal to, so I have v times du over dx. So v in this case is 4x minus 4 times du over dx. So the derivative of the numerator, derivative of u, is just 1. That's differentiating x plus 3. Then I've got minus u is equal to x plus 3 times the derivative of the denominator. So dv over dx, so differentiating 4x minus 4, that just gives 4. And I got to divide that by the denominator squared, or v squared, which I can write as 4x minus 4 and the whole thing squared. Now I can expand the brackets and then simplify it, but since the differentiation is done, I'll just leave it as it is. But in an exam, I think it will be better if you do the multiplication and simplify it down. Okay, let's take another example. So let's say we have y equals, let's take a quadratic terms now. So let's say we have x squared plus 3x minus 4 divided by, say, some cubic term, say x cubed plus 4x. And just to help remember the quotient rule, I think it's probably a good idea to just write it down for the first few times that you do the quotient rule. I think it just helps you remember it. So it was v du over dx minus u dv over dx. And I just remember it as the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. So if I fill everything in here, v is equal to x cubed, and I'll rewrite that as u over v. So that's my u, that's v. So v is equal to x cubed plus 4x times du over dx. So differentiating u, I get 2x plus 3. Then I've got minus u times dv over dx. So u is equal to x squared plus 3x minus 4 times dv over dx. So differentiating x cubed plus 4x, I get 3x squared plus 4. And I've got to divide that by the denominator squared. So this squared will give x cubed plus 4x squared. And once again, you can simplify it if you expand the brackets, but something like this, I think I'd leave it at this stage because the differentiation is done. And unless you're told to write it in the simplest form, I think it's okay to leave it like this. Okay, I'll take one last example. Let's say we have y equals x squared plus 3x plus 4 divided by x plus 5. Okay, once again, let's write down the quotient rule. So dy over dx is v times du over dx minus u times dv over dx divided by v squared. And in this case, once again, that's my u. That's equal to v. So v du over dx, that would give x plus 5 times 2x plus 3, because du over dx, differentiating x squared plus 3x, I get 2x plus 3. And I have minus the numerator, which is x squared plus 3x plus 4 times dv over dx. So dv over dx will be equal to the derivative of x plus 5, that's equal to 1, divided by the denominator squared. So x plus 5 squared. And in this case, I think I'll simplify this because it's not that difficult, this one. So expanding this first bracket, I get x times 2x, that's 2x squared. Then I got x times 3, that's 3x, plus 5 times 2x, that's 10x. So that gives plus 13x, plus 13x. Then I have plus 5 times 3, that gives plus 15. Then I've got minus x squared plus 3x plus 4 divided by, and I'll expand this bracket as well. I'll leave that one factorized because I want to factorize them, so don't want to expand them. So that's x plus 5 squared. And I can simplify the numerator because 2x squared minus x squared, that gives x squared. 13x minus 3, that gives plus 10x. Then 15 minus 4, that gives plus 11. Divided by x plus 5 squared. And I don't think we can factorize this one. No, I cannot factorize the numerator, so I'll leave it at that point. So that would be dy over dx.